A NoSQL or Not Only SQL database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in relational databases. Motivations for this approach include simplicity of design, horizontal scaling and finer control over availability. The data structure differs from the RDBMS, and therefore some operations are faster in NoSQL and some in RDBMS. There are differences though, and the particular suitability of a given NoSQL DB depends on the problem to be solved. The appearance of mature NoSQL databases has reduced the rationale for Java content repository implementations. NoSQL databases are increasingly used in big data and real-time web applications. NoSQL systems are also referred to as Not Only SQL to emphasize that they may in fact allow SQL-like query languages to be used. Many NoSQL stores compromise consistency in favor of availability and partition tolerance. Barriers to the greater adoption of NoSQL stores include the use of low-level query languages, the lack of standardized interfaces, and the huge investments already made in SQL by enterprises. Most NoSQL stores lack true ACID transactions, although a few recent systems, such as FairCom c-treeACE, Google Spanner and FoundationDB, have made them central to their designs. History: Carlos Strozzi used the term NoSQL in 1998 to name his lightweight, open-source relational database that did not expose the standard SQL interface. Strozzi suggests that, as the current NoSQL movement departs from the relational model altogether, it should therefore have been called more appropriately NoREL, referring to no relational. Eric Evans reintroduced the term NoSQL in early 2009 when Joel Carson of Last.fm wanted to organize an event to discuss open-source distributed databases. The name attempted to label the emergence of an increasing number of non-relational, distributed data stores. Most of the early NoSQL systems did not attempt to provide atomicity, consistency, isolation and durability guarantees, contrary to the prevailing practice among relational database systems. Classification: there have been various approaches to classify NoSQL databases, each with different categories and subcategories. Because of the variety of approaches and overlaps, it is difficult to get and maintain an overview of non-relational databases. Nevertheless, the basic classification that most would agree on is based on data model. A few examples in each category are column accumulo, Cassandra, HBase, document, clusterpoint, Couchbase, MarkLogic, MongoDB, KeyValue, Dynamo, FoundationDB, Memcached, Redis, React, FairCom c-treeACE, Graph, Allegro, Neo4j, OrientDB, Virtuoso. A more detailed classification is the following, by Stephen Yen. Performance. Ben Schofield rated different categories of NoSQL databases as follows. Examples: document store. The central concept of a document store is the notion of a document. While each document-oriented database implementation differs on the details of this definition, in general, they all assume that documents encapsulate and encode data in some standard formats or encodings. Encodings in use include XML, YAML, and JSON, as well as binary forms like BSON, PDF and Microsoft Office documents. Different implementations offer different ways of organizing and/or grouping documents, collections, tags, non-visible metadata, directory hierarchies, compared to relational databases. For example, collections could be considered analogous to tables and documents analogous to records. But they are different. Every record in a table has the same sequence of fields, while documents in a collection may have fields that are completely different. Documents are addressed in the database via a unique key that represents that document. One of the other defining characteristics of a document-oriented database is that, beyond the simple key document lookup that you can use to retrieve a document, the database will offer an API or query language that will allow retrieval of documents based on their contents. Document store databases and their query language, Graph. This kind of database is designed for data whose relations are well represented as a graph. The kind of data could be social relations, public transport links, roadmaps or network topologies, for example. Graph databases and their query language, key-value or KV stores. Key-value stores use the associative array as their fundamental data model. In this model, data is represented as a collection of key-value pairs, such that each possible key appears at most once in the collection. The key-value model is one of the simplest non-trivial data models, and richer data models are often implemented on top of it. The key-value model can be extended to an ordered model in which keys are maintained in lexicographic order. This extension is powerful in that it allows efficient processing of key ranges. Key-value stores can use consistency models ranging from eventual consistency to serializability. Some support ordering of keys. Some maintain data in memory, while others employ solid-state drives or rotating disks. Here is a list of key-value stores: KV, eventually consistent; Dynamo, REAC, KV, immediately consistent; FairCom c-treeACE, KV, ordered; Berkeley DB, FairCom c-treeACE c-treeATG, FoundationDB, IBM Informix CISAM, Infinity DB, Memcached, NDBM, KV, RAM, Coherence, FairCom c-treeACE, Gemfire, Hazelcast, Memcached, Redis, OpenLink Virtuoso, XAP, KV, solid-state drive or rotating disk, Aerospike, Bigtable, CDB, ClusterPoint XML database, Couchbase server, GTM, FairCom c-treeACE, Hiberi, Keyspace, LevelDB, Memcached, MongoDB, Oracle NoSQL database, Tarantool, Tokyo Cabinet, TupleSpace, OpenLink Virtuoso, Object Database. DB40, Gemstone S, InterSystems Catcher Copyright, Jade, NeoDATISODB, Object Database++, ObjectDB, ObjectivityDB, Object Store, ODABA, Post, OpenLink Virtuoso, Versant Object Database, Wakendag, ZODB, Tabular, Apache Accumulo, Bigtable, Apache HBase, Hypertable, Nzia, OpenLink Virtuoso, TupleStore, Gigaspaces, Apache River, Tarantool, OpenLink Virtuoso, Triple Quad Store Database, Apache JNA, MarkLogic, OntoText OWLIM, Oracle NoSQL Database, SparkleDB, Virtuoso Universal Server, hosted, Amazon DynamoDB, Cloud Ant Data Layer, Data Store on Google App Engine, Freebase, OpenLink Virtuoso, Multi-Value Databases, D3PIC Database, Extensible Storage Engine, Infinity DB, InterSystems Catcher Copyright, Northgate Information Solutions Reality, the original PIC-MV database, OpenQM, Revelation Software's Open Insight. Rocket U2, Cell Database, NoSQL databases on the cloud. NoSQL databases can be run on premises, but are also often run on IaaS or PaaS platforms like Amazon Web Services, Rackspace or Heroku. There are three common deployment models for NoSQL on the cloud. Virtual machine image. Cloud platforms allow users to rent virtual machine instances for a limited time. It is possible to run a NoSQL database on these virtual machines. Users can upload their own machine image with a database installed on it, use ready-made machine images that already include an optimized installation of a database, or install the NoSQL database on a running machine instance. Database as a service. Some cloud platforms offer options for using familiar NoSQL database products as a service, such as MongoDB, Redis and Cassandra, without physically launching a virtual machine instance for the database. The database is provided as a managed service, meaning that application owners do not have to install and maintain the database on their own, and pay according to usage. Some database as a service providers provide additional features, such as clustering or high availability, that are not available in the on-premise version of the database. Native cloud NoSQL databases. Some providers offer a NoSQL database service which is available only on the cloud. A well-known example is Amazon unregistered trademark ASimpleDB, a simple NoSQL key-value store. SimpleDB cannot be installed on a local machine and cannot be used on any cloud platform except Amazon unregistered trademark S. Notable examples of NoSQL databases available on the cloud in each of these deployment models: see also, CAP theorem, comparison of object database management systems, comparison of structured storage software, faceted search, triple-store, distributed cache, references. Further reading, Pramod Sadalaj and Martin Fowler. NoSQL Distilled, A Brief Guide to the Emerging World of Polyglot Persistence. Addison Wesley. ISBN A0-321-82662-0. Dan McCreary and Ann Kelly. Making Sense of NoSQL, A Guide for Managers and the Rest of Us. ISBN A9781617291074. Christoph Strauch. NoSQL Databases A, Munir A.B., Hussein S.A. NoSQL Database, New Era of Databases for Big Data Analytics, Classification, Characteristics and Comparison A, Kaya Rend. Analysis and Classification of NoSQL Databases and Evaluation of Their Ability to Replace an Object Relational Persistence Layer, Ganesh Krishnan, Sarang Kulkarni, Dharmesh Kirat Dadbawala. Method and System for Version Sharing, Consolidating and Reporting Information A, Sugam Sharma. A Brief Review on Modern NoSQL Data Models, Handling Big Data A, External Links, Christoph Strauch. NoSQL White Paper. Hochschule der Medien, Stuttgarter, Stefan Jedlich. NoSQL Database Lister, Peter Neubauer. Graph Databases, NoSQL and Neo4j, Sergey Bushik. A vendor-independent comparison of NoSQL databases, Cassandra, HBase, MongoDB, Riak. Network World A.